Welcome everybody to Science Live at Wild Basin. This is a live program, so bear with us. It's just like when you are listening to your teacher live and a dog may bark in the background. Anything like that could happen in our live program today. My name is Dianne Folkerth, and I am the Environmental Education Coordinator at Wild Basin. And I'm here with my colleague today, Dr. Darren Proppe, and he is actually at Wild Basin, whereas I am, like many of us, at home doing this program. And we are so glad you're here. We're so happy that you've joined us for this first live webcast of Science Live at Wild Basin. We're going to be talking today about some of what Darren does as a field biologist here at Wild Basin. We're going to be watching some videos that we have already filmed out in the field, meaning out on the preserve itself. And then we're going to give you guys a chance to ask us questions. Anything you want to know about being a field biologist or birds, or if you may even have just a science question in general, you can type it in the Q&A and we'll do the best that we can to answer those questions right now live for you during this program. Darren, do you want to introduce a little bit about what you do at Wild Basin?
Yeah, sure. So welcome everyone this morning. Good to have you. My name is Darren Proppe. I am the research director here at Wild Basin. And that means that we get to study all kinds of things that we have going on here at Wild Basin, which is a 227-acre preserve here west of Austin. And we have lots of different species, some that are endangered or some that are rare. And some that are quite common, but we spend lots of time out in the field as well as in the lab, just trying to understand through the process of research what's going on. In many ways, the reason we do it is so that we can conserve these species for the future.
Great. I have one question that I want to address, and I started to type an answer, but I think I'll just say it out loud. As part of the process for registering for Science Live, once you click the link, it does ask you to enter your name, and it does ask for an email address. So for students, if you have an email address, you can enter that. Also, you could enter an email address, I believe, that is not a real email address, and then it will let you in. It is asking for that. Ms. Tovar, I know you were asking that question of us. So I hope that helps. Okay, great. So one of the things Darren mentioned, his job as a field biologist is to go out and conduct studies on the preserve at Wild Basin. We also have other people that we work with, other biologists, other educators who are at our partner preserves around Austin. And so for the first part of the program, we visited right next door to Wild Basin. We visited our friends at the City of Austin's Vireo Preserve. It is also a nature preserve, and we visited and talked with their biologist, Laurel Moulton. And so in just a second, we are going to play a video that we filmed there where Darren, our field biologist, and Laurel, their field biologist, banded birds. It's one of the ways that scientists it's one of the pieces of technologies that scientists have to track and monitor birds species, know what species are in the area, and get a little bit of handle on bird migration. Though we are in the city of Austin, the live music capital of the world, bird banding does not mean that the birds are forming a rock band. It is something different. A band meaning something that wraps around something like a ring or a piece of jewelry or a watch. That's the type of technology that bird banding is. And so we're going to play a short video. Let me check the questions really quickly, see if there is anything else. Yeah. Okay. Let's go ahead and start our very first video. This morning we are out here with our field biologists here, not at Wild Basin, but at the City of Austin's Vireo Preserve. Wild Basin is 227 acres. The City of Austin's Vireo Preserve, where we are right now, is 212 acres. So together, our two preserves protect around 440 acres of Texas hill country habitat and protect that for our native plants and animals that live here. Together, we are one of the preserves, we are two of the preserves in the Balcones Canyonlands Preserve System, which protects over 32,000 acres here in the Central Texas area. In just a little while, we're going to go back over to Wild Basin and talk about some other things that field biologists do. This morning, the biologists are going to be banding birds, talk about why that's important to science, talk about what a field biologist does, and talk about what you might be able to do in your life if you're interested in science, biology. My dad is also a bird biologist, but his focus is on waterfowl and ducks. And when I was a kid, I had absolutely no interest in what he was doing at his job. And it wasn't until I took a course in undergrad at University of Texas that took us out on field trips, and we would look at not just birds, but mammals and herps, which are snakes and reptiles and amphibians. But for some reason, I just was attracted to the birds, and I'd never known before that there were so many different species, and that they all looked different, and that they all sang different songs. And then once I started learning them, it was like I could not unlearn it. And then every time I would go outside, I would just be curious about what I was hearing and seeing. This is called a mist net, and this is what we use to catch birds. So you can see it's very hard to see, especially if you're standing this direction. So the birds, we kind of put it in an area where there's low shrubbery. And so when the birds are just moving through foraging, they will hit the net and get caught. And there are 4 trammels, which are these individual things, and each one has a pocket. So when they hit the net, they'll pull their wings in and then fall down into the pocket and just rest here. And then when we come along, you just have to be very careful when you take them out, and there's certain techniques that you use to safely get them out so that they don't get injured.
There are banding stations all across North America and really across the world, but there's been several different programs that have standardized effort at these banding stations. And then you can start to do some comparisons. So when you talk about survival, when you talk about how many young are being produced, you can ask, are there more young being produced in certain regions of the United States or in certain types of habitats, or urban versus rural habitats? So again, we can start to answer questions, and that's really important because then we can understand a little bit about what kind of habitats we need to keep if we want survival and reproduction to stay high in these birds.
So this grip is called bander's grip, and it's just a way of keeping the bird secure, but also keeping them safe. So I have the wings folded down so they can't injure their wings. A lot of times birds, especially chickadees, titmice, they're sneaky and they'll try to push my fingers up and then duck their head under to escape. And sometimes they're successful if you don't have a good grip on them. These bands are from the USGS, and each band has an individual unique number on it. So there are actually 9 digits on this tiny little band. So you have to make sure before you put the band on the bird that you know what the number is. You also have to always know what species you're banding. So this would be Carolina chickadee. You just open the band a little bit, stick it in this part, and then when you close it, there's no way for it to injure the bird because it can only close whatever amount that circumference is. Let me just carefully put it on. So people often ask, do the birds, can they feel the band? It's kind of like a person wearing a watch or a piece of jewelry. You notice it a little bit at first, and then after a while, you don't notice it anymore. I'm also going to check for fat, and birds hold their fat in that area of the wishbone, which is like right here. If they have a lot of fat there, it's kind of like a white kind of a color and not the pink color. He really doesn't have any fat. I'll give him a 1. And I'll have to subtract the weight of the bag.
Banding birds, well, it's a ton of fun. It's not something that's done by anybody in the backyard. You definitely want to have permission. There's federal regulations for banding birds, as well as state requirements and even local requirements. So now, having said that, if this is something that's really interesting to you, there often are local banding stations nearby that you might be able to visit, and you may be able to volunteer and learn some about these birds at that banding station. So there can be opportunities for those that want to get involved and want to do this the right way.
If you find yourself being interested in bird, I would suggest going and getting a bird book, or you can even download free apps on your phone now and just look out in your backyard, set up a feeder, set up a bird bath, and just take a look at the birds that are outside. And there's areas that you can go to all over Austin that are free, like the Austin Nature Center, close to Zilker Park, Emma Long Park, Barton Creek Greenbelt, Hornsby Bend. There's a lot of cool places where you can see birds year round, pretty much.
All right, well, I hope you enjoyed our clip about banding. Welcome back to the live section here. I hope that you appreciate my new hat. You can get one of these yourself if you like. I think they're like $30 on Amazon. It could be the next cool trend. I don't know how likely that is, but anyways, there is actually a reason that I am wearing this here today, and it's not necessary to make a trend. So what I wanted to show you was one of the bands that we utilize to mark these birds. So right behind me here, I have a banding kit. So hang on just a second, I'll pull out a string of bands. So there it looks like a little fishing tackle box, and it's wonderful actually for keeping everything in one place for banding birds. So here's a string of bands. So there's about 50 of these bands on here. Now, bird legs are not all the same size. They're different sizes, and so we have different bands for different types of birds as well. And this would be a relatively small songbird, but let's see. I'm gonna try to put one right up to the camera here. Can you read it? Can you read the number? Remember, they said in the video there's a 9-digit number, and every one of these has a unique number. So that's actually the reason for my hat. Now, to be honest, if you were here with your good eyes, you might be able to read these straight off the band, but my old eyes don't do so well. So I can read it here now with my little magnifying glass, 2, 6, 2, 1, and then we have 3, 6, 7, 2, 1. So that's the unique ID for this band right here, at least for one of the bands here on this string. Now, I noticed that someone asked about why you put the bands on the birds, and there's a reason that it has this unique number, because there's a lot we can learn about the birds if we recapture them, right? So birds are moving, they're migrating, they're going to different locations, and we don't catch a whole lot of them again, but there is a portion that we do. So every once in a while you get a bird that was banded, say somewhere up north, and then you capture it after it migrates down to the south, or maybe when it's in a stopover area in the middle of its migration. And I can read that, and I can actually find out where that bird was banded and learn more about where that bird is moving. And in fact, if you find a band, you can actually get information about that as well.
Hey, Darren, we have another question. Someone asked, do the bands bother the bird?
You know, we don't have any indication that the band does bother the birds. So, they're very lightweight. In fact, there are regulations as far as how heavy the bands could be, because if we put a heavy weight on a bird, it would bother it. But they've done a number of studies with birds where they have looked at how well birds survive, whether they have bands or don't have bands, and there doesn't seem to be any difference. So we don't have any indication that it's painful or that it bothers the bird at all.
That's great. And I just want to go back in the question and answer. One student made a really good observation of how the mist net works. They said the mist net is a little bit like a spider catching its prey. And I thought that was a really, really great observation. It wasn't a question, it was just an observation.
Yeah, in some ways it is. So the bird does get kind of wrapped up and the bird is not able to, on occasion they do free themselves, but for the most part, they don't. And so we come in and we free them, and it's a process just to get them out of the net. But again, it's not something that harms them. It just holds them in place until we can get them.
Great. And someone else asked, can the bird get out of the band?
In theory, no. So these are metal and they are designed to, if you seal them up correctly, it's a little ring. And so it should be pretty difficult for them to get out of the band. Having said that, I think that occasionally they do. There are some birds that have pretty strong beaks and they may be able to actually pull metal open on occasion, but that's not the norm. Most of them, they don't even know that it's there or care that it's there. So they're not even trying to pull it off. That's what I typically see.
Yeah, I think a good way to think about it is, wearing a ring. You don't really know that it's there. It doesn't harm you. It doesn't really hurt. If it does, it's not the right size ring. But that kind of thing. I have one question for you. What is the farthest that a bird, you're not the only biologist and Laurel's not the only biologist who bans birds all over the world, really. What is the farthest that a bird has been tracked using this banding technology?
So I'd say it's from pole to pole. We've had birds that were abandoned essentially in the north and then recaptured near polar regions of the south. And there's a pretty famous story of one bird called Moonbird, who they abandoned in 1995 in Argentina, recaptured 3 times between 1995 and 2007. And this bird would go use the polar regions from the north and the south each year. It would go back and forth. In fact, it flies so far that they nicknamed it Moonbird because over the last time it was seen was 2014, but over that time period, this bird has flown the same distance or longer than it would be from here to the moon.
So from pole to pole of the Earth, over and over and over, equaling the distance between the Earth and the moon.
Correct. Yep.
Fascinating. So one of the last questions, and this sort of might take us into the next section and the next video and technology that we're going to look at is, what is the rarest bird in our area, in the Austin area, that has been banded?
So in the Austin area, I'd say we have the golden-cheeked warbler here, which is an endangered species. And so it's probably, as far as a bird on a large scale in the United States, it's probably the rarest bird that we would capture around here. There may be other birds that show up that are rare here, but that's a rare one that uses this area for nesting.
Great. And we are going to see some photos of the golden-cheeked warbler in the next video, and we're going to see a study using some different technology that Darren and his students are using at Wild Basin with acoustic recorders. So we're going to shift from talking about the bands, the physical bands on birds, to a different type of technology that field biologists are using, and that is acoustic recorders. What we mean by that is that records sounds, everything that's happening. These recorders are around the preserve at Wild Basin and they're recording sound. And if you think about it, even when you're outside or anywhere you are, there are sounds that are going on around us all the time. So before we do this, before we start recording, watching the video where we talk about the recording sounds, let's do a quick, super simple experiment at home or school, wherever you are. Let's be quiet for 5 seconds and think about the sounds that you're hearing around you in the space wherever you are, whether you're at school, at home. Let's do it. Everybody ready? Go. Okay, I'm not going to have time to go over and ask everybody what they heard, but I'll just offer to you what I heard. I'm at home at my house. I've got construction going on across the street. We have several pets, and right on cue, I heard a cat outside my door. And earlier, I heard my middle schooler practicing trombone. So we have a lot of sounds that are going on around us in the environment. And the next question is to think about all those sounds that you sort of hear during the day when you're at school, or if animals are hearing those sounds. Some of those sounds are outside, then the animals that live in our urban environment here in Austin are hearing those sounds too. And so one thing to consider is, how do those sounds affect the animals? So let's watch our second video, and we'll talk about a little bit how sound might affect those animals. Here we go. Hey everybody, we're back here at Wild Basin. We've come over here from the city of Austin's Vireo Preserve, which, if you look behind me, Wild Basin protects 227 acres, including up the hill behind me. Right to the ridge line is sort of where the city of Austin's Vireo Preserve starts. So both preserves are together, helping to protect more than 440 acres of the Balcones Canyonlands Preserve. We're going to talk now with Darren, and he is going to introduce us to his acoustic monitoring project, which is another one of the fascinating projects that a field biologist does. And he does it right here at Wild Basin.
So the soundscape is actually a very important part of habitat for songbirds. And that's primarily because they use song to communicate. So that's how they're talking to males, females, young birds, predators, and so on, which means that when we have noise in the environment, it can really impact songbird systems, their function of their communication. So we've started investigating that here at Wild Basin by placing what we call passive acoustic recorders across the landscape. We have 15 of these different places in the preserve, and they're little boxes. We'll take a look at them in just a minute here. And what they can do is they can record sound all day, every day, or in segments of every day for months at a time. Here we are at one of our acoustic recorders. So like I said, there are 15 of these around the preserve. This is recording basically 1 minute out of every 10 for 24 hours a day, every day of the year. And it's going to do this for 2.5 years. So we can really get an idea of sort of how things change around here. I also brought my sound level meter here with me. So we can take a measurement right next to the highway, but let's take a look here and see what our sound decibel looks like here. So if you were able to look at that, you see that we're sitting right around 30 decibels here. So we're here at Highway 360, right outside of the Wild Basin gates. As you can see, we have quite a bit of traffic that's moving here behind us. And as you can tell, it's pretty loud. In fact, I have to raise my voice a little bit so that you can hear me about the traffic. Let's see comparatively what we get out here. And you can look, it fluctuates quickly. So as a car passes by, you're probably going to see it go up higher. So going from 30 to 80 is, you've doubled the sound level many, many times going over to the road. So you can imagine here, much quieter. If you're a bird, your ability to communicate here is much better. Technology can be a challenge, but technology can also be a real benefit when we talk about doing research. So we're pretty early into this project. So these recorders are going to be up for 2.5 years. And they are sitting at around probably 6 months that they've been up at best, maybe actually a little bit shorter than that. So we're early to make conclusions, but we have looked at some of the data, and we've also compared it to some data that we recorded in golden-cheeked warbler habitat. So this is separate from these sort of general recorders that are getting the soundscape of the environment. In that case, we put these recorders actually in the territories of golden-cheeked warblers. We had 3 territories, and what we found is if you look at how loud it is in a golden-cheeked warbler territory, in general, it's quieter than the habitat as a whole, which suggests that these warblers, among other things they may be choosing for their habitats, may also be assessing the level of noise and looking for quieter habitats. So a lot of times people ask, what does a field biologist do? And the answer is the field biologist does a lot of different things. Some of our days are spent out here in the field, just like we are now. We're checking equipment, maybe we're monitoring birds directly or capturing birds, but there's also analysis. There are computer-based portions of our job as well. We're back here in the lab, and we're ready to do some analysis of some of the data that we collected today. The first one we're going to look at here is some acoustic recordings. Now I have a couple of different programs that will open up sound and basically make them look like a graph so that you can look at them and you can compare them. And you will also be able to listen to those sounds. The program I'm going to use today is Audacity. This is actually a free program that you could even use in the classroom if you wanted to record a sound and have a look at it as well. So what you see on what we call the x-axis, we're going across the bottom here, is time. All right, so this is sound over time. But you see on the y-axis, and I actually have 2 files open. So here's a y-axis, here's a y-axis, is frequency, going from low frequency to really high frequency, right? So this is showing us what's happening across the sound spectrum. And when you look inside of this, as the colors get darker, that means that there's more power or more intensity there. So the sound is getting louder. So if you look at these 2, the top one is recorded at location WB4, which is where we were in the field when we looked at a recorder. The bottom one is recorded at WB3, which is quite close to the highway where we originally took a sound file. So even looking at that, they look dramatically different here. So I place my cursor right here. I don't know what this sound is. It appears to be some kind of a burst of energy. And then there's a number of other things as well. So let's start it and let's just let it roll for a few seconds. The scrub jay. All right, so we'll stop it right there, but you get the idea. Most of what I heard was bird songs. There's a little bit of background noise there. Could have been the road because it's still not super far away. Could have been some wind noise. But now let's do this. Let's switch to WB3, which is the one that pretty much overlooks the highway. And we'll start from that same location on the track. All right, so we'll stop there. What a dramatic difference. Now, do you see, can you actually see those little bird calls in the background? They're there, right here. But look how much easier they are to detect up there up top. That's the difference that the birds are dealing with. So golden-cheeked warblers are an endangered species that nest primarily here in central Texas. So anytime you have small populations, there's more concern about sustaining these populations. How long will they last in the future? And since we do have a small population, a very narrow range, we need to think about the habitats they use. How do we keep those habitats intact? Here around Travis County and the Austin area, we have a large amount of growth, right? There are many, many people that are moving into the area, which is a wonderful thing in many ways, but it also presents some management challenges. And so we need to understand, what do they need? What do they need in regards to trees, to vegetation, to other species, but also in relation to sound. Because you can imagine you create this beautiful park, it's next to a highway, and it's empty. And why is it empty? Why is it going unused? Sound could be one of those variables. All right, guys. So I've got our sound level meter right here. So this is what we're using in that video to measure sound. You can probably, I don't know if you can see it or not, you might be able to see it going up and down even as I talk. This sound level meter here costs several $1,000s, but what's cool nowadays is you can actually get a sound level meter on your phone that will read pretty similar to this one. So it's something you guys can actually measure on your own, on your phone, on your computer, in the classroom, that kind of thing. I want to let's go to some questions now. So go ahead, Diane, if you have some questions.
Yeah, we've got some really good ones related to sound. Some of y'all, I went back and read through the comments after we did the super quick sound experiment at home. You observed that you heard your dog barking, or you heard footsteps out in the hall, you heard kids in the classroom next door. That's the kind of thing to think about related to us. But we've got one question that is, can you tell the different songs from every bird?
You know, every bird does have a unique song. And when we actually survey birds, so we go out to figure out what's here, we do most of that surveying through sound. So yes, we actually go out, we listen. I can tell you when I hear a golden-cheeked warbler. I can tell you when I hear a white-eyed vireo, a blue jay. Yeah, we can identify them by looking at them. But I would say that 80% of the time, that's just a rough estimate, you identify birds through their songs.
Yeah, that's great. And I know that at Wild Basin also, some biologists from the city have been identifying even specific birds by their song, that even their song differs from one bird to another in the same species.
When I was a master's student, I actually did that. So we worked with a species called grasshopper sparrows, and we would use the graph of their song that you saw there to actually identify individuals, and they were consistently different. So you could be like, that's bird A, that's Joe, or whatever, you could actually identify them.
Yeah, that's great. We've got another question that came in that says, why do you need to track sound?
Yeah, so sound, when you think about bird song, what they're actually doing is they're communicating. So it's just like us talking to each other. So if you have sound, it's getting in the way of that. So you imagine a really noisy room, it's hard for you to talk. Well, in birds living in a noisy area, it's like they can't get away from that room, right? And so it might ultimately impact them in the sense that they can't actually carry on the normal functions that they should. And therefore you might see populations start to shrink or go extinct even because of that. So that's why we monitor sound. We want to know how it's impacting birds as well as other organisms. And then we want to look for ways that we can sort of make it so it's not as noisy, essentially. So are there options that we have to control sound to help keep these birds around?
Yeah, I mean, it's one thing to think about for all of us, even if we're not the biologists who are studying this sound. Are there things that we are doing as humans that impact wildlife, the wildlife around us? And if we are, are the sounds we're making impacting their lives? And if so, what can we do about that in the future? How can we help save these bird species? There was one more question that is sort of related to all the videos, but I'll go ahead and answer it here so I don't lose track of it. And that is your job fun to you?
Yeah, I love it. Absolutely. Uh, I enjoy birds. Some of you asked about that. Yeah, I love birds. I love being outside, and all these little ways of sort of figuring out how to um, solve problems. Essentially, maybe sometimes it's to analyze things, but then maybe it's to try some new things that will help birds, animals live next to humans. Yeah, I think it's great.
Yeah, yeah, great, wonderful. Okay, so guys, we're going to keep moving along. I'm going to try to get to most of the questions that I see, but I did want to tell you that if we don't happen to answer your question live over the air right now, don't worry. We're going to answer them and put them on our website at wildbasin.org. And I'm going to send that link out to your teachers so that you guys can come back to our website and see your question answered. In case we don't have time to do it today, because we're going to try to stay on time. So we have talked about two types of technology that field biologists are using to track and study birds. The bands that they put on their legs with the unique numbers so they can tell where they've been or if they're in the area. We've talked about acoustic recorders that actually record sound of the birds' calls and also of other things that are going on in the environment, possibly some sounds from humans that are impacting the birds. So we're going to get into and introduce a third type of technology that field biologists can use in research. And in this case, Darren has used this technology, not at Wild Basin, but in Michigan. And we have some pretty cool footage and a video to introduce drone technology and infrared cameras. Darren, do you want to talk about that for a second?
Sure, yeah. So I suspect that some of you have probably used drones as they get more popular. A great way to get a good view of an area, things like that. When we talk about using drones for research, there's more regulations that are required as far as using drones. So for example, we're not allowed to, even us, allowed to just fly drones around at Wild Basin without getting permission from Travis County to do so. So there is some regulation there. But within those bounds, you can do some really interesting stuff with wildlife, with birds. They've been used, for example, to count deer, to estimate deer populations, to count bird colonies at remote islands that you can't otherwise get to, but they can fly the drone over and they can count birds. So there's actually a lot of value for drones in the wildlife field, in biology as well. So this is some of the questions that we've been exploring and that we'll get into in this video. So yeah, go ahead, let's take a look at the video. And if you got a question, put it in the Q&A box as the video rolls.
Great.
We sometimes tend to be frustrated with technology. Sometimes we think that technology invades our natural space, and there's an element of that that is true. You think about roads and their impacts. But there's also an element of technology that's really beneficial to research. So this here is a DJI Inspire 1, and it has a regular camera as well as a thermal camera that can be attached to it. And we've used it for a couple of different songbird studies. One of the studies that we did, we used the thermal camera, and we actually tried to find things that are hard to find that create heat. So one thing you can envision that might fit that would be a bird nest. Bird nests are challenging to find, especially in places like grasslands, which is where we worked. You've got these fields or, far as you can see, and birds place nests at the bottom of the grasses in these fields. The grass can be waist high, really, really tough to find. But even eggs actually produce a heat signature. And so what we did is we put this drone with a thermal camera up in the air, flew it around the field, and you could actually find these heat signatures or these nests using the drone. What we're doing here today is we have attached a thermal camera to our drone. What a thermal camera does is it senses heat. It's actually not a camera, it's really a sensor that can detect how hot an object is. So as you can see in the image, one hand here has a heat pack in it, which is up to 130 degrees Fahrenheit, was it 50 some degrees Celsius? And the other hand does not have a heat pack in it. And so you can tell that the hand with a heat pack is much warmer than the hand that is without a heat pack. Same way when you're going searching for a nest, you would see that hot nest amidst cooler grasses. If you're working with a species that's more in the forest, the grassland, that doesn't get exposed to humans as much, you still got to think about that, right? Because drones are great, but they're loud. And to a bird, it might look like a predator. So it could create some stress. So we got to be careful. All right, so it's been a great day in the field. Let's go to look at some of that data in the lab. These were taken in Michigan. These were up in a grassland, and they demonstrate a couple of different things. So the first thing you can see here is this large light area here. That's actually a path. So we're in the middle of a grassland, and that's a cut path. So even just having some differences in grass cover actually changes the heat that's coming out of the ground, which changes your image. But if you take a little closer look where that arrow is pointing right there. Remember that hot pack that we saw earlier today? That's one of those heat packs placed in the middle of a grassland. All right, it stands out pretty well. This is probably taken from 30, 40, maybe even 50 feet above the grassland. So you got some good height on this photo. Right in the center of your image is a nest. So we found this with a thermal camera We went in to actually check out what it was, and here you go, 4 song sparrow eggs in this nest. Here's another one. It's actually, believe it or not, a single egg, which you couldn't always see with a thermal camera, but in this one you could actually tell it was just one egg. And here's one of a couple of my students. They found this in the grasslands, and can you see it? It's right there. This is something that without thermal imagery, you'd almost never find in the grasses after a bird is actually hatched and is actually out of the nest. So they show you here a video. In this, you can clearly see one of my students, but just above the student here, you can see the nest. And she's searching for the nest. Actually, much easier to visualize on our camera than it was for her to see out in the field. Having technologies like drones, like acoustic recorders, and even the equipment that we use for banding is critical to understanding birds, understanding bird migration, understanding bird habitat choice, understanding how birds are impacted by human activity. And so these are a couple of examples of the way technology has enhanced our ability to understand birds.
Okay, great. We have some questions that have come in. I want to start us off by asking one quick question, especially about the video where we saw your student. And when you say a student, you mean a college student, right? Helping you out with your research. And so this is what she was doing. And it looked like she was moving her arms like this. Why was it so hard for her to find that nest that we saw right next to her?
So these nests and the eggs are tiny. So in that case, they're in grasslands. The grass is about as high as my waist. And if you all take a look at your thumb, the end of your thumb, that's probably about the size of the eggs, maybe a little smaller than my thumb. So maybe depending on the size of your thumb, it's about the right size. But these eggs are tiny. So they're deep down inside of grasses. They're tiny. And so actually seeing them and picking them up is really, really tough to do. But that drone can pick up the heat. So it actually has an advantage over our eyes when we're looking for those nests.
Yeah, that's great. So another image that I think that you have is to sort of, sometimes it's really hard to understand when you see a thermal image for the first time, what you're actually looking at. And it was a little bit clear that you saw a human figure standing there trying to search through brush. But do you want to show us the image of you and one of the test images that you did that shows what a thermal camera does, that it picks up heat?
Yeah, let's see if I can pull that up here.
Okay,
All right, can you see it?
we see it.
Excellent. So you may have seen this move before. I don't know. Yes, that is me on the thermal camera. And there are a couple of different ways you can color your image, but in this case that you see here, the whiter the pixels or the parts of that picture, the hotter it is. So you can see where my arms, where I don't have a shirt, I got a short sleeve shirt on, so where my arms are showing, my head, that's the brightest spot. So that's definitely where you have the most heat that's being picked up. So in the video, for example, that was, I think red was the hottest spot, whereas a blue-green was cooler. So there's a couple of different ways that you can set that up in the settings inside of your drone and thermal camera, but that's what you're looking for. And as you can see here, we do have some fun with our thermal camera as well.
Yeah, someone asked in the chat, is he dabbing? And yes, that's why we chose that photo to show you guys. So that was a nice dab, Darren. So you also mentioned that drones are loud. And so I think we have another small short video to show everybody about, it's one of the reasons you have to carefully think about where you are going to use drones, especially when studying birds. You want to demonstrate that one?
Yeah, let's take a moment and we can pop that video up.
Yeah.
a brief clip to show really what the drone sounds like. So I'm popping it up and down there, not the way I would normally fly it, but just to give you an idea of sort of, especially as you're revving it up, what it sounds like. So, that was one of the concerns. We see drones as being a really cool thing for studying birds, but we also want to make sure that it doesn't create new disruptions. So you can think of the noise, but also think of that fact that you just have something flying in the bird's airspace, right? This is where birds kind of own this section of airspace, and now you've added something to it. Um, so we've actually done some studies with that. We haven't found a lot of impacts of drones on birds yet, but we're early on in that. So I don't think we can make conclusions as far as actually what's happening in relation to noise and drone movement.
Is
But
that your drone right there behind you in the lab?
I have the drone right here behind me. I'm not going to fly it in here, so don't ask. But but that is the drone. The camera you see there is actually the visual camera, not the thermal camera. You can switch it out for the thermal, but yeah, it's a DJI. I noticed a few of you said you have a DJI as well. It's a fairly common brand of drone and a fairly reliable one, so that's good. That's what you want.
Great. We have a couple of questions. We're going to have some questions here at the end, and then I think we'll wrap it up. So if you guys have any questions, anything you want to ask about the technology that you saw, the banding or the sound recording, the acoustic recording, or the drone use, type them in the Q&A box, and we'll try to get to them. One of the ones that I see is, what's the fastest bird in the world?
That would be, from everything I know, peregrine falcon. And they tend to get those speeds of 200 miles an hour or so in the dive. So when they're actually coming from high up in the sky and they're diving down to capture prey, and then they actually impact the bird because they catch other birds, and they hit them so hard that it instantly kills them, basically, so that they can eat them. So yeah, peregrine falcons will be the fastest.
Yeah, and if you're interested in the fastest bird in the world and peregrine falcons, there is a peregrine falcon who returns to the tower at the University of Texas. They've nicknamed her Tower Girl, and she has built a nest every year, and she's laid some eggs, but they haven't necessarily been fertilized eggs that have hatched. So that is a peregrine falcon that we have that is nesting here in Austin. And maybe someday we'll have some brand new peregrines from Tower Girl's nest at the university. A couple other questions that are a little bit related that I see are, what do you do with the eggs, and do you ever keep the birds?
So we do not do anything with the eggs. We leave the eggs in the nest. So really, the goal here is to find the eggs. And the reason we want to find the eggs is we want to know how these birds are doing. So in other words, you have them around, which is great, but to be doing well as a population, they have to be producing young that also survive. And if you can't find the nest, it's very hard to know that. So when we find the nest, what we do is we monitor it. So that means we'll go back and we'll check on that nest every couple of days to see if those birds hatch and then fledge. But we are never going to actually take the eggs away from the nest. And same would go for the birds, the adult birds. We're never keeping adult birds from banding or from any of the other stuff we're doing. We're always releasing them back into the wild as quickly as we can. So we're trying to be non-invasive and yet monitor them so that we can ideally change habitats, reduce noise, and whatever it is that we need to keep them successful.
Yeah, great. So we had a question earlier in the section about bird banding that's related to a question that's sort of come in now. And one of them was, do the birds ever get hurt in the nets? Are they ever so big that they get injured when they get caught in the mist nets?
You know what? The birds don't get injured when they get caught in the mist nets, because the mist nets are very flexible. And so it's not like a tight situation for them. They're just going to hit the net, they fall into the pocket. Some will struggle a little bit. In other words, they kind of will jump around, and especially chickadees. If you like chickadees, they have personalities. They like to do little back flips in the net. which gives us a little bit more fun getting them out, right? We got to unroll them and get them out, but they're not hurt when we do that. So it is why you want to have a permit, because there's regulation to make sure that the people that are taking birds out of the net know how to get them out of the net safely. So once you follow that procedure properly, then no, these birds are not getting hurt. And the same goes, I saw a question about the drones, and asked about if a bird gets hurt if a drone hits it. I would imagine that if a drone hit a bird, it would get hurt. Although sometimes there are videos out there of eagles attacking drones, where a case where the drone actually gets hurt or destroyed because they're actually quite powerful. We did a study with tree swallows, which is a songbird, to see how they would respond. And we actually had guards on our drone for a period of time to see if they would come in and it would be a problem. And then they tend to avoid the drone. They tend to stay away from them. But certainly, if I was flying a drone and I saw birds flying closely to it, I would take the drone down, because yeah, it could injure them if it hits them.
Yeah, great. There's one other question that I had related to the acoustic recorder sounds, and it's something that I forgot to mention at that time, and that is, what is the funniest or most unusual sound that you have recorded on those acoustic recorders?
So here's the thing. A lot of times when people are out in the field, they forget that they're recording sound. And so, when you're out in the field by yourself, you often will do things that you would not necessarily do in a group of people. You can probably think of what some of those things might be, but I have certainly recorded a number of, burps, farts, all kinds of wacky stuff that people think they're doing by themselves, and you get to hear it later.
Excellent. Okay, well, if anyone has any other questions, you can ask them in the next couple of minutes, but I think we're gonna wrap it up. This has been our very first webcast for Science Live at Wild Basin, where we feature real field science that's going on at Wild Basin and other preserves on the Balcones Canyonlands Preserve System, to introduce to you guys what it is that field biologists do, a little bit about why their research and why their studying is important. We've gone over bird banding, acoustic or sound recording, and also infrared imagery taken from drones. And so these are all ways that field biologists use technology to help study and do research. We have one last question that I'll end with. Darren, I'll let you answer this. What is your favorite bird?
My favorite bird. Well, I grew up in Texas, in San Antonio, and I moved away for 20 years. And the first bird I ever worked with was the golden-cheeked warbler, and that's what really got me started in this career path. So I've got to say that the golden-cheeked warbler is my favorite bird. However, one of my favorite bird songs is the canyon wren, which is also found in this area. And I would challenge you, go find a canyon wren song on the web, and then go see if you can find a canyon wren out in a natural area around here, because they are very cool sounding.
Great. Well, thanks so much. I want to say, though we can't be with you guys, most of us are, many of us are going to school at home or working from home. Wild Basin is open. The preserve and the trails are open. So if you guys would like, tell your families, say, hey, I want to go on a hike. You can go to our website, wildbasin.org, and reserve a free hiking pass and come out and hike the trails and see where we filmed these videos and where we're doing these studies about birds. I want to thank the City of Austin and Laurel Moulton for allowing us to go over and band birds with her. I would like to thank Applied Materials Foundation for providing the funding for the Science Live at Wild Basin webcast, Wild Basin staff, and all of you guys, the students. You guys are from Austin ISD, Pflugerville ISD, Round Rock ISD, and Lake Travis ISD are the ones that we have joining us in today's program. So stay curious, stay well during this time, and stay wild. And we'll see you guys a little bit later. Thank you.